Hello, ladies and gentlemen. This is your Unit 7 Quest review, where I'm going to be going through the answers from your review sheet. And remember, this will pretty much mimic exactly what to expect on your unit quest tomorrow, So make sure that you're following along here, So which ratio best represents the sine of x in the right triangle shown below? Excuse me. Sip of water. Okay. So, whoa. Pen's off a bit. So we're talking about that angle right there. And so remember, the sine ratio is opposite over hypotenuse. This side is our opposite. That's our hypotenuse. So 28 over 53, which we see right there. The one to the right, and the diagram shows, a right triangle below. Okay, thanks. Which ratio represents the tangent of PLM? So PLM, we're talking about that angle up there. So tangent of L is opposite over adjacent. This is our opposite. This is our adjacent. And so it's 4 over 3. Go down to the next one. Which ratio represents cosine of A in the accompanying diagram of ABC? So talking about A, adjacent, hypotenuse, 5 over 13, boom. In the accompanying diagram of a right triangle ABC, AB is 8, BC is 15, AC is 17, and the measure of ABC is 90. Fair enough. So we're looking at the tan of C, so that's the opposite over the adjacent. So what is tan of C? 8 over 15. Now we're going to go down to finding the missing side. So using these trig ratios and one of the side, we'll be able to find that other side measure. So given the right triangle in the diagram below, what is the value of x to the nearest foot? So in reference to this angle here, this is our hypotenuse, this is our adjacent side. So we're going to go cosine of 40, because that's the one that involves adjacent and hypotenuse. It's going to be 14 over x. And multiply both sides by x to get that available here. So I have x times the cosine of 40 is equal to 14. And then pretty much we divide by the cosine of 40. And so x is equal to 18.27, round to the nearest foot, 18. As shown in the diagram below, a building casts a 72-foot shadow on the ground when the angle of the elevation of the sun is 40 degrees. How tall is the building to the nearest foot? So we're trying to find this height right here. So we'll just call that x. All right, and so in reference to this angle here, this is our opposite. This is our, not hypotenuse, sorry, adjacent. And so the one that involves that is tan. So tan of 40 is equal to the opposite over the adjacent. And I just multiply both sides by 72. Cancels over here, and x is equal to 60.42, round to the nearest foot, 60 feet. Excuse me. An 8-foot rope is tied from the top of a pole to a stake in the ground as shown below. If the rope forms a 57-degree angle with the ground, what is the height of the pole to the nearest tenth of a foot? Again, we're just finding the missing side here. So in reference to that angle, this is our opposite. This is our hypotenuse. And that is going to be sine. So sine of 57 is equal to x over 8 multiplied by 8. X is equal to sine of 57 times 8, which is equal to 6.71. It says round to the nearest tenth of a foot, 6.7. Moving over here, okay, to the nearest tenth. All right, so let me read the whole problem. Yolanda is making a springboard to use for gymnastics. She has an 8-inch tall springs and wants to form a 16.5 degree angle with the base as modeled in the diagram below. Okay, so never mind the picture, right? Here's a right triangle. Here's the side we're trying to find. What are we going to use, right? So this is our hypotenuse. This is our opposite side. And so we're going to use sine. So sine of 16.5 is equal to 8 over x. Multiply both sides by x. That cancels. I get x times the sine of 16.5 is equal to 8. Divide by the sine of 16.5. Shrink this down. I'm just talking to myself here. And x is equal to 28.17. It says round to the nearest tenth of a foot. Okay, so 28.2 inches. Down to our last three. In the diagram of triangle ABC shown below, BC is 10, AB is 16. To the nearest tenth of a degree, what is the measure of the largest acute angle in the triangle? Okay? So we're actually having to do a couple calculations here, right? Because we need to know what the two angle measures are, and then we can decide which one's the largest. Okay? Now they're both acute in the sense that they both have to be less than 90. So we could cancel this one out right here, right? They have to be less than 90. So that one's out. Okay? And so we look at, all right, what angle are we talking about here? We're talking about B and A. All right? So let's talk about B first. Okay? So B, in reference to B, this is our adjacent, this is our hypotenuse, right? And so we're going to use cosine. So the cosine of B is equal to 10 over 16. We're going to use the inverse of cosine. So we're telling our calculator, hey, we got this ratio here. What is this angle measure? So the measure of angle B I'm getting 51.32 degrees. Okay? Which says round to the nearest tenth, so sorry, 51.3. Then we're going to do the same thing, except now we need to find out, well, we probably don't need to, right? Because if this one's 51.3 degrees, clearly that one has to be larger than this one, right? Because we know that A and B, the measure of those two angles, must add up to 90. And so if one of them is 51.3, clearly that's going to be the largest one. But just for fun, let's still solve for the other one, okay? So AB is 16, BC is 10, right? So now we're talking about angle A here. So this is now our, AB is, 6, okay. Hold on. BC is 10. There we go. I'm like, what? All right. So this is our opposite side now, and this is our hypotenuse. So I'm going to go the sine of A is equal to, again, 10 over 16. And I'm going to use the inverse sine function to let our calculator know saying, hey, I got this 10 over 16 ratio here. which angle measure has that ratio? And that's 38.7 degrees. Okay. So, we didn't answer the question yet, right? The whole point of the question was which one's the largest one? Well, clearly, 51 is the largest one there. But it's cool to see that we got both angle measures just by being given two of the sides. Okay, so we're going to do the same thing here. All right, so we're trying to find the measure of angle S. So this is our hypotenuse. This is our adjacent side. And so cosine of S, so we have to use cosine, is adjacent over hypotenuse, which in this case, our adjacent is 60, and our hypotenuse 65. Okay, then you take the inverse cosine on both sides. You get S is equal to the inverse cosine of 60 over 65. And we get 22.61. And if you round that up to the nearest degree, we get 23. All right, last one. Kayla's cutting up two right triangles from wood to use for an art project. Two of the right triangles she cut are shown below. Okay, if ABC is similar to DEF with right angles B and E, BC is equal to 15, AC is equal to 17. What is the measure of F to the nearest degree? Okay, so really what we're trying to find here, and it goes from the fact of you know, just from your similar triangles, okay, the fact about similar triangles is that all these angle measures are the same. The only thing that's different about both of these triangles is the size, right? ABC is clearly larger than DEF. And so what you have to remember then is that even because they're similar, that means that this angle is going to be equal to this one. So all we'd have to do really is find the measure of angle C, and that will be the same as the measure of angle F. Okay? So, that being said, let's go ahead and do that. So this is our hypotenuse. Again, our adjacent. So cosine of C is equal to adjacent over hypotenuse. So in this case, adjacent is 15, hypotenuse is 17, and we're going to inverse cosine. Okay, so inverse cosine, 15 divided by 17, we get 28.7, which rounded to the nearest degree, bada bing, bada boom. Okay, so we're looking for this answer key. Here's the video for those of you that want to watch it, and hopefully it was helpful. Good luck, you guys.